Welcome back, everyone. In this video, I'll be continuing the lecture on antiderivatives. Now, in the last video, what we did was we talked about what an antiderivative is. We know a little bit about the constant of the antiderivative. We'll see how to actually use it in this problem. And we talked about how we actually know a lot of formulas for antiderivatives already. And that's because we know a lot of formulas for derivatives and we just do it in reverse. All right, so number one here says compute the general antiderivative for f of x equals 3x to the negative 2 power. And then something that's going to be important about antiderivatives and something they're associated to is going to be very relevant to pointing out the domain. So we're going to have to make sure we point out the domain in these types of equations, or at least kind of plant that seed that we know that we should think about what the domain of the antiderivative is. All right, so with that, we have to go ahead and do the antiderivative first. Now, the antiderivative, it really depends on what you want to call it as far as notation. I'm going to use capital F. So capital F of x equals, well, what is the antiderivative of f of x? Well, like with derivatives, I'll just kind of remind you and go through the pieces, is we leave numbers that multiply functions alone. So this 3 is going to be left alone. And then we want to do the antiderivative of x to the negative 2. Well, the power rule for antiderivatives states the following. We have just x. We take our old power and we add 1 to it. So it's the opposite, because with the derivative rule we subtract. And then we divide by the new power. So this is what the power rule for antiderivatives said. We add 1 to the power and then we divide by that new power. And now we can go ahead and do one thing before we can actually simplify. So it might be easy to think about doing all this out and then writing plus c at the end. But you do want to be proper, because we want to make sure that we're actually computing the antiderivative. And with the constant c, so the number c added on, go ahead and add c on right now. You want to get in the habit of doing that immediately as soon as you do the antiderivative. So we've done that. And now really the only thing you want to do here is just simplify. What is negative 2 plus 1? Well, that's negative 1. So we have 3x to the negative 1 over negative 1. Then we have our plus c. And 3 over negative 1 is negative 3. So we can leave it like 3x to the negative 1 plus c. This is absolutely fine. If you want to get rid of the negative exponents, we're not doing anything with this, so you don't necessarily have to. But if you want to get rid of the exponent, you can bring the x to the negative 1 to the bottom, and it's just x to the 1 or x. Now do keep in mind, we've already done the antiderivative. So this is our answer. This is the antiderivative. Now, the other part of this question we wanted to ask is, or answer is, what is the domain of the antiderivative? Well, the domain of the antiderivative, you don't really have to think about it being anything special. It's just a function. What is the domain of this function? Well, the plus c is not going to do anything because that's just adding a number that will never affect our domain. But we cannot divide by 0. So our domain here is all real numbers, except what? What can we not plug in for x here? Well, we can't plug in 0. If x is 0, we're dividing by 0. So it's all real numbers except x equals 0. And I just wanted to do this problem with this extra part here to really plant the seed of what's going to happen in the future. Is there are going to be times where we need to know, is our antiderivative doing something wrong as far as its domain and as far as it's related to our problem? And for this problem, we're not really doing anything with this, so we don't need to go any further. But in the future, there might be a reason why this could be bad for what we're trying to accomplish. So it's a good idea just to point that out right now. All right, so with that, number 2, we're just pretty much going to now focus on practicing these antiderivatives using our formulas. Now, the one thing that's kind of a little annoying is we don't have any notation yet. So you can't really say do the derivative of each part. We do the antiderivative of each part. We don't have like a d over dx, d over dt to really write that. We will have notation in the next sections, but not quite yet. All right, so the most general antiderivative, all that means is plus c at the end. Well, they tell us to use c, so we're going to use plus c, but whatever they tell us to use, that's what we'll use. Now we want to do the antiderivative of this, and remember, of our rules, we do not have a rule for division. So what we have to do is simplify this first. We cannot have a division. So what I'm going to start by doing is just rewriting it. 3 plus t squared over the cube root of t, just based on everything we know about derivatives, is we always rewrote it as powers. With antiderivatives, it's the same thing. So I'm going to rewrite that as t to the 1/3. Now what you can do is bring this to each part. So we got 3 over t to the 1/3 plus t over t to the 1/3 plus t squared over t to the 1/3. All right, and this helps us. Why does it help us? Make those ones a little longer. This helps us because what we can now do is we can go ahead and use exponent rules to make the fractions go away. So the first one here, there's no t on the top, which means we can just bring the t to the 1/3 to the top, and we get 3t to the negative 1/3. Now for the second term, we have t to the 1 on top and t to the 1/3 on the bottom. To simplify that, we subtract the top exponent minus the bottom. And 1 minus 1/3 is 2/3, so this is t to the 2/3. And then plus, and then do the same exact idea for the last one. We have t squared over t to the 1/3. We want to go ahead and subtract top exponent minus bottom exponent, and 2 minus 1/3 is 5/3. All right, and just, you know, reminder that you have to know really how to do this stuff, and you probably have done enough problems dealing with fractions that you can kind of do this in your head like me. If you're not there yet, just remember that for this last one here, 2 is the same thing as 6 over 3, so I'm doing 6 over 3 minus 1 over 3 gives me the 5 over 3. All right, but once we have this is something we can do the antiderivative of, because we can do the antiderivative of each part. There's no multiplications, we'll be fine. So g of t, pretty much just going to use the power rule 3 times. So we got 3, number stays by itself. How do we do the power rule? We take our old power, negative 1/3, we add 1 to it, and we divide by that new power. And you do the same thing for all of them. So these are just powers of t. So this next one, we have t to the 2/3. We need to add 1 to that power, and we divide by the new power, plus, and then t to the 5/3 is what we had. We add 1 to that power, and we divide by the new power. All right, and now let's go ahead and simplify all these powers. So for the first one, negative 1/3 plus 1 is 2/3. So this will be t to the 2/3 over 2/3 plus the next one, we have t 2/3 plus 1 is 5/3, and then that's over 5/3 plus, and then the last one we have 5 over 3 plus 1 is 8 over 3. We get t to the 8 over 3 over 8 over 3. Now you can definitely simplify this, and you want to, because we don't really want to ever have fractions inside fractions. All of these fractions in the bottom you can flip and change it to multiplication. So every single one of these. So on the top of the first one here, we have 3t to the 2/3, and instead of dividing by 2/3, I'm going to multiply by 3 over 2. And for the t to the 5/3, instead of dividing by 5 over 3, I'm going to multiply by the reciprocal, 3 over 5. And then last one here, t to the 8/3. Instead of dividing by 8/3, it's the same thing as multiplying by 3 over 8. So we just flipped each one of these fractions and changed to multiplication. And there's really only one left to do, which is simplify. The 3 times 3 is 9, so we got 9 over 2 t to the 2/3 plus 3 over 5 t to the 5/3 plus 3 over 8 t to the 8/3. All right, now I intentionally left something off. What are we missing? And maybe you realize it at the beginning and you wanted to point it out. Maybe you did point it out to yourself. We need to have a plus c. The moment we start doing the antiderivative, which was right here. So this was our first step. We simplified the original function here, so nothing happened there. But as soon as we started doing the antiderivative, we need a plus c at the end. So on all of these, I should have a plus c to be very proper. But then our final general antiderivative is this right here. It's not very nice. The thing about this is, yes, you can factor some things out because there is a t in common with everything. There's a 3 in common with everything, but better just to leave it like this. Right, the next problem is going to show us that we can actually go back 2 steps. So in the previous ones, we just wanted to find the antiderivative, but when you read this one, hopefully you realize you're going to have to do that twice. So it says a particle is moving with acceleration a of t equals t squared minus 3t plus 8. And we haven't seen something like this, so I'm just going to highlight it. We have s of 0 equals 0 and s of 1 equals 20. And we want to find the position s of t of the particle. Now, before I go into anything else, I want to talk about what this is giving you here. One thing you should notice about the directions is there's no mention of what we should use for our constant or our coefficient of the antiderivative. And the reason we're not told is because there is not going to be one at the end. These 2 things are telling you how to solve for C. Right? So comparing that to just number 4, since it's on the screen, this says use C for the constant of integration, constant of the first antiderivative, and D for the constant of the second antiderivative. Well, we haven't done 2 yet, so that might not make a lot of sense yet. But the point is, in this problem, we aren't given those directions. So we're going to be able to solve for C. But another important thing is that the acceleration is the second derivative of position. So s prime prime of t equals a of t. Well, what we want to do is go back to the original s of t. So that means we have to do the antiderivative twice. Now, don't try to think about this and try to do it all at once in your head. What we want to do is just do one at a time, just like when we started doing the second derivative of a function, we did it one after the other. So s prime of t in words is the antiderivative of s prime prime of t. And this is s prime prime of t right here. So what do we want to do? Well, we want to go ahead and do the antiderivative of this. So when we do the antiderivative of this, what's going to happen is this is going to give us s prime of t. This is also v of t, which is the velocity. But for the purposes of this problem, we just want to use s prime of t because we're wanting to reference getting back to s of t. All right, so when we do the antiderivative of this, remember we do the antiderivative of each part. The antiderivative of t squared, we add 1 to the power. Since that's a whole number, I can just add 1 to get 3 and divide by the new power of 3. Then I get a minus. I leave the 3 there. When I do the antiderivative of t, that's really t to the 1 power. So when I add 1 to that, I get t to the 2 power, and I divide by the new power of 2. And then the kind of the special one that I mentioned when we talked about the antiderivative rules is that when you have just a number, it's so easy to think that this is 0 just because that's the derivative rule, but it's really 8 times the variable, which is t. So if it was x, it would be 8 times x. But this is why this step here is why I really emphasize the plus c is you must add the plus c here. Okay. So this is our first antiderivative. It's not that great. It's pretty messy, but It's a part of our steps. So we've done one. All right, now we want to do the second one. Let me actually use this color. So we want to get back to s of t. Well, to do s of t, we would take its derivative, s prime of t, and do the antiderivative. We would go to do exactly what we just did again. So s of t is the antiderivative of s prime of t. And we just figured out that s prime of t is this. All right, so how are we going to do the antiderivative of this? Well, one thing that might help, which I'll go back and do, is because I have this 3 on the bottom and this 2 on the bottom, I'm going to slightly rewrite this. So this is going to be 1/3 t cubed minus 3/2 t squared plus 8t plus c. I'm not going to change those. The reason I'm slightly rewriting these is when you do the antiderivative, you want to just look at the power. So having this 3 in the denominator may throw you off a little bit, especially at first. But when it's written like this, we know that the 1/3 is just going to stick around. The antiderivative of t squared would be t to the 4th, because we add 1 to the power, and divide by the new power of 4, minus, bring the 3/2 along for the ride, and then the power of t, once again, we add 1 to 2, we get 3, and we divide by the new power of 3, plus, and here we have the antiderivative 8t. Well, 8t is really 8t to the 1 power. So when we add 1 to that power, we get 2, and we divide by the new power of 2. Now here's what might trip you up a little bit, but you have to remember what c is. C is a number. And what's the antiderivative of a number? It's a number times the letter, just like we did with a at the beginning. So this is actually c times t. And then the last thing that might be slightly confusing as well is that we have to add something else, because every time you do an antiderivative, you add a new constant. And so I'm just going to go to the next letter after c, and that is d. So d is the constant from the second antiderivative. All right, so the main thing here is that you've got the general formula. Now we're going to use these two things to actually solve for it. But before we do, I'm going to clean up what we have. So s of t equals this. If we simplify this, 3 times 4 is 12, so we get 12 in the denominator. We have 1/12 t to the 4th minus. In the second part here, these 3's actually cancel out, so it's just 1/2 t cubed plus, and here we have 8/2 actually cancels out again, and we got just 4 t squared plus c t plus d. All right, now if you want a big hint from me, what you want to do is anytime you have s of 0, you want to use this one first. All right. And what we're going to do, what this says is if we plug in t equals 0, it should equal 0. So what I'm going to do is take our formula here. Since I want s of 0 to equal 0, the way that sets up is if I plug in t equals 0 here. Now I'll go ahead and plug it in, but you probably know what's going to happen. So I'm plugging in t equals 0. And it's got to be set equal to 0. So this left side is s of 0. The right side is 0, what it equals. And now what you should notice is that literally everything over here is 0 except the d by itself. What this says is d equals 0. Well, that's great because that just let us solve for d, and we can plug that in. So I'm going to plug it in. And now all we'll have left to do is solve for c. S of t equals 1/12 t to the 4th minus 1/2 t cubed plus 4t squared plus ct. The d is 0, so if I add 0 on, it doesn't do anything, and we're just left here now. All right, and the way you want to think about this is, pretty much anytime you solve for c or d, you plug in something set it equal to something, and then you'll be able to solve for it like this. And then you take the thing you just figured out and plug it back in your formula. So our formula is still S of t equals all this stuff. We have d equals 0. All right, well now at this point we have to use the other point, but this one will let us solve for c. So now that we've gone through the problem, I want to just fix this up and say we had c and d, so these two things are telling us how to solve for c and d. All right, well s of 1 equals 20. What does s of 1 look like? Well, that's when we plug in 1 everywhere. So we're going to have 1/12 times 1 to the 4 minus 1/2 times 1 cubed plus 4 times 1 squared plus c times 1, and that's supposed to equal 20. And now any power of 1 is 1, so this is just 1/12 times 1 is 1/12 minus 1/2 times 1 is 1/2 plus 4 times 1 is 4 plus just c equals 20. And this is going to take some time to solve if you do it all by hand, but we know we could get a common denominator. We can multiply both sides by 12, get rid of the fraction. You just want to solve this for c. We'll go ahead and just, at this point, simplify the left side as a fraction. So 1/12 minus 1/2 plus 4. And if you hit enter, you just want to see it's reading it right. I'm kind of just taking a shortcut, and it gives us 43/12. So this stuff added together gives us 43/12. But once again, you should be comfortable with finding a common denominator if you want to do it by hand. So we got 43/12 plus c equals 20. And that means c equals 20 minus 43/12. Well, what I'm going to go ahead and do now is just finish that off in the calculator. But once again, you can do it by hand. Get a common denominator. We have 20 minus 43 divided by 12. And if you want to hit enter once again, just make sure it's reading it correctly. It is, and we get 197/12. Kind of an obnoxious answer, but that's what it is. So c is 197/12. And that means our final s of t is this with that c value plugged in. So s of t equals 1/12 t to the 4th minus 1/2 t cubed plus 4t squared. And then c is 197/12 and it multiplies by t. Now, one thing you may have noticed throughout this section is that most of the problems deal with the power rule, and that's because it's probably the one you have to get used to the most when you integrate, because you have a different rule. You have to add 1 to the power, divide by a new power. It just looks similar but different than the power rule for derivatives. I know this video is getting a little long after that last one, but we have one more problem, and it should be much quicker than the last one, so we're going to go ahead and do it in this video. This one says if f prime prime of x equals 4x minus 6e to the x, find f of x. The nice thing is we've pretty much done one like this just before. We want to use c for the constant of the first antiderivative and d for the constant of the second antiderivative. So just to kind of put it in perspective of the last one, where we had c and d here, before we plugged in anything to solve for c and d, we would have stopped here if we weren't given that information that was extra. So we're just doing the two antiderivatives. Make sure you use the appropriate letter that it tells us to. Well, the first antiderivative would be f prime of x, because the first antiderivative of the second derivative, we just take off one derivative. And we want to do the antiderivative of each part. I'm going to go ahead and rewrite f prime prime of x right above it. So we got 4x minus 6e to the x. The antiderivative of 4x, well, we leave the 4 there. And the antiderivative of x, well, we add 1 to the power, we get x squared, and we divide by the new power of 2. Minus 6, and what's the antiderivative of e to the x? That is itself. Pretty much the best and easiest derivative and antiderivative rule. Now what we want to do, we just did the first antiderivative, so we want to add a c onto it. But you have to make sure you follow the directions here. If you add d for this one and c for the other one, the answer technically is not correct because we need to follow the directions. Now I'm going to go ahead and simplify this. So 4 over 2 makes 2. We got 2x squared minus 6e to the x plus c. And now for f of x, what we're really after, we'll get there with one more antiderivative because we just need to do one more antiderivative to get rid of all the derivatives. All right, so we got to do the antiderivative of this. And I definitely encourage you at this point to maybe pause it, see if you can get it right, and then watch the rest of the video. Now, when we do this, the 2 stays put. The antiderivative of x squared, we add 1 to the power, we get x cubed, and we divide by 3. Minus 6, and the antiderivative of e to the x is, once again, e to the x. So that's pretty much always going to say e to the x, even if you do 100 antiderivatives. Now, like with the last one, we don't leave the c alone because the c is a number. When we do the antiderivative, we multiply by the variable, which is x. And then plus, now that we've done the antiderivative of every part, it's plus the constant of our second antiderivative, which we're told to use d for. So I'm going to have a plus d. And now at this stage, you're not wrong because there's really nothing to simplify. But you can do one thing, and that is I can kind of rewrite the first one as 2 over 3 x cubed minus 6e to the x plus cx plus d. All right, but that would be our general second antiderivative, or the general f of x, when the second derivative is 4x minus 6e to the x. Now, anytime you want to go ahead and check your answer, you can do the derivative, you can do the second derivative for this one and see that you get back here. But that's really the only way you can check. Right. Now, this was a pretty brief, but also thorough introduction to antiderivatives, and we'll see a lot more as we go forward, and I'll see you in the next video.